Okay, so we're going to write the explicit rule for geometric sequence. So the explicit rule is a function that tells you any term in a geometric sequence based on which term it is, and you can do that without finding each individual term. So if we talk about the recursive rule, we need to know what R is. R is the common ratio, and we're going to take that and we can find the next term by multiplying that value to get the next one. So for instance, on this one, sometimes that value is easy to figure out if you don't know it. So here we have a geometric sequence, or at least the beginning of one. And so if we look at 7, what number can we multiply 7 by to get 35? Well, 7 times 5 gives us 35. Now, for it to be a geometric sequence, we have to be able to reuse that number and multiply it each time to get the next one. So we can test that. 35 times 5. Well, 35 times 5 should give us 175. So turning it on, 35 times 5 gives you 175. So that's our value for R. Now we can continue in that way. 175 times 5 gives you 875. The next one is 875. And that's fine if all we have to do is a few in a row like this, but what if we want to find the 100th term or the 50th term or something like that? Then it's much easier if we can write a function, and that's what we're going to be doing with the explicit rule. So this is how we're going to do it. We're going to look at the patterns that are involved and break it down so that we can find the rule that makes sense. So the first thing we're going to do is we're going to look at these values right here. That first term right here is a sub 0. So a sub 0 is 7. So we're going to start, that's our 0 term, the first term. So this is what we're starting with. Then the first one, and then a sub 1 is our second term actually. So it's a little bit confusing. A sub 2 is our third term. A sub 3 is going to be 875. And we know R. So in order to write the explicit rule, there are two numbers that are extremely important. We need to know a sub 0, and we need to know R. And I'll show you how we're going to find it. So we're going to take these terms and the subscript. So that's going to be our value for y. And for x, I'm sorry. So a sub 0, x is 0. A sub 1, subscript is 1, so x is 1. A sub 2, x is 2. A sub 3, a sub 4 is 4. Now here we skip. So a sub 10, x is 10. A sub x, well, our subscript is x, so we're going to write x for our value for x that we're going to use. And the value for y is just the value of that term. So a sub 0 is 7. A sub 1 is 35. A sub 2 is 175. And we have 875 for a sub 3. And we'll worry about these later. So this is what we're going to do. We're going to break it down because just by looking at this, it's probably kind of hard to see a rule that we're going to be able to write as a function. I can't see it, and so I don't expect you to be able to. So we're gonna break it down over here, and I'm going to put a 7 because, well, that's what we're starting with. That's the beginning. Then we're going to use what we do for the explicit rule. We're going to multiply that by 5. 7 times 5 is what gives you 35. And I'm just going to write it out like this. Then we take 35 times 5, and that's how we get 175. But this right here is already equal to 35. So I'm just going to bring that down. 7 times 5, 35, and we just have to multiply another 5, right? So we have 7 7 times 5, 7 times 5 times 5, and then we can bring this down. So 7 times 5 times 5 should be equal to 175. So we're not quite where we need to be yet. But if we do 7 times 5 times 5 times another 5, now we have 3 5s we're multiplying. That should give us 875. So as we go down looking at this, you should start to see a pattern. 7 times 5 times 5. This will be 7, and then notice there are 3 5s here. X is 3. 2 5s here. X is 2. 1 5 here. X is 1. How many 5s? There's that many. There's not any 5s at all. We're not multiplying 7 by 5 at all. Okay? So this, we should have 4 5s. Now, that's fine. That's easier than what we did before. At least it is in my opinion. But down here, we need how many 5s? We need 10. After a while, it's going to get kind of annoying putting 10 different 5s there, right? It's going to be 5 times 5 times 5. Repeat it. We're multiplying by 5 10 different times. So now what we need to fall back on is we have to ask ourselves, is there an easier way of writing that? So when we have repeated multiplication like this, we can represent repeated multiplication using exponents. So 7 times 5 times 5 times 5 times 5 is the same as 7 times 5 to the 4th power. This is 7 times 5. How many different 5s? 3rd power. 7 times 5 to the 2nd. And then this one, it's just as easy to write like this. Actually, maybe a little easier, but the exponent would be 1, right? 7 times 5 to the 1st power. On this one, 7 times 5 to the 10th power. So 7 times 5 to the 10th power, we can calculate that. And that's going to be 7 times 5, the exponent key, 10, and we get a very large number. 68359375. So I'm kind of out of space here. I'm going to write it over here. 68359375. So what is that? 6,835,009. Oops, that's in the wrong place. 68,359,375. That's what that answer is. Now, like I said, that's a big number. But the real thing was to find out our explicit rule. So we're going to decide, well, what's y equal to? Now on this one, we have x, we have y. How can we represent this? Well, notice the pattern. It looks like we're going to have a 7 in every single one, right? Oh, by the way, let's go back up here. 4, 3, 2, 1. We have a 7. What would make sense for this pattern? 4, 3, 2, 1, 0, right? 7 times 5 to the 0 power. And just in case, remember, if we take 5 and raise it to the 0 power, that should be equal to 1, right? So if we take 7 times 5 to the 0 power, we get 7, which is what we have here. So that's what our pattern is. It's going to be 7 times 5. The exponent will be equal to whatever value x is. Well, down here, it's going to be 7 times 5. And what is x? Well, x is just x. So when we write the explicit rule, that's what we're going to write. 7 times 5 to the x power. That's an exponential function. but that's what our explicit rule is. Okay. Now, as I said, sometimes this will be easy to find. If it's not, sometimes it's not. So if we go this direction, it's multiplication, right? The way you can find out what the multiplication is very easily, if you can't, if you just do it in your head or find it simply, is go the opposite direction. Now the opposite of multiplication is division. So to get this way, you multiply. To go backwards, you divide. So if we take 35 divided by 7, that would be equal to 5. It doesn't matter which two you pick, you should be able to get the same exact answer. 175 divided by 35 should be equal to 5. Okay. So no matter which two you pick, as long as they're adjacent to each other, next to each other, you'll get 5. And that's going to be the R value, the common ratio. Now the reason that's important is because sometimes you might get something like this. And we're going to do this one the same way. We need a sub 0. A sub 0 is, so 0, 30. That's our first term, that's our second term, right? Okay, so 24, 19.2. When we put our pattern, that's going to be the first thing. But we need to know what R is. So what we need to do is we need to divide, because I can't tell what it is. I know that's going to, it's like, it's getting smaller, right? When you multiply by a number, we're used to whole numbers at least, and integers getting bigger. So what we need to do is we need to divide this one divided by this one. That means this goes first. 24 divided by 30, and we end up with 0.8. Or just plain old 8. So what that means is if we take 30 times 0.8, or 0.8, we should get 24. And that's what we get. So to get this one, we have 30 times 0.8, or if you feel more comfortable, 0.8. Either one is fine. Now we're going to take this and we multiply that times 0.8 again. So each time we're using this value. So what do we have? We have 30 times 0.8 times 0.8, and we have 19.2, which is this. Okay, so we can find all of those values, multiply this one again, times 0.8, and we have 15.36. Down here, so we should be able to see a pattern already. As soon as you see what the pattern is, you can stop writing this out like that. So this is going to be 30 times 0.8, and then how many of these? How many 0.8s? 3. This will be 30 times 0.8 to the second power, like that. So down here, for eighths of 10, it'll be 30 times 0.8 to the 10th power, and down here, 30 times 0.8, and what's x? Well, it's x. And that's what y is. So our explicit rule will be 30 times 0.8 to the x power. And you can calculate each and every one of these to the 4th power. So 30 times 0.8 exponent key 4 equals 12.28. So I'm gonna round that off to 12.3. This one, 30 times 0.8 exponent key 10, and what do we have? 3.22. So I'll call that 3.2. I'll round it off. Okay, so there's the table completely filled in. The most important thing about this table is to be able to use it to find that pattern. So you look for the structure, and then once you know what that structure is, then you apply it to that the function that you're going to write, your explicit rule. So that's the explicit rule. Y equals 30 times 0.8 to the x power.